Pre-calculus, we're here in section 7.4. We're going to be talking about the double angle and half angle identities. With a lot of this stuff that we're going to talk about, you really need to write down the relationships so that you can have access to them when you're doing the problem. So I'm just doing like a quick overview, a kind of a glancing, if you will, at what we have going on. So if you look over here, we're going to start off with the double angle identities, and you'll realize that the double angle identities literally come directly from the sum formulas that we talked about in section 7.3. So if you were to just replace the alpha and beta of those sum formulas with theta and theta, you would get these. So if we had an angle that, if we knew what theta is, if we had a theta and you doubled the angle, so let's say you were dealing with an angle such as, well, you'll see in our examples. So anyway, you guys get the idea. Sine of 2 theta, if you know the sine of theta and the cosine of theta, then you multiply 2 times the product of that and you've got the sine of 2 theta. And you could see that there's this whole list of cosine of 2 theta, and these are really related, and I'm hoping that you guys can see that you can move easily from one to another if you consider the relationship that sine squared theta plus cosine squared theta is equal to 1. That's what's at play in all of these different ones. And of course, tangent of 2 theta is going to equal what we have here, and that's directly out of the alpha beta sum formulas that we talked about in the last section. And then these half angle formulas, which we could probably derive by doing a little bit of substitution with these formulas here and solving for, going up to the top, solving for one particular angle or one particular function like tangent of theta. If we solve for tangent of theta, we might get something that looks like this. And similarly, we could do that with the other ones. But here, honestly, I just want you to memorize them. So make sure that as we're working on the problems, you're copying them down and you're working with me through all of the work. So that's our notes. That's our vocabulary. Let's get started with the first question. So this first one says that if we have the sine of theta and we know that the sine of theta is 2/3 and theta has its terminal side in the first quadrant, find the exact value of each. Well, let's go get some formulas. So let's see, we've got our formula here. We know what the sine of theta is, but if we want to use this formula here, we need not only the sine of theta, but also the cosine of theta as well. And so if the sine of theta is 2/3 and we know that we're dealing with the first quadrant, I'm just going to go back old school to right triangle trick, guys. So sine is opposite over hypotenuse. So the opposite is 2, the hypotenuse is 3. The question is, what is this side? Because this will give us information about the cosine. And so when I work some magic mentally with a squared plus b squared equals c squared, the Pythagorean theorem, what I'm getting is that this is going to be, let me do it, I can do it, 9 minus 4, 5, square root of 5 is what I get for this value. Another way to do this, by the way, is that you could exploit the idea that sine squared theta plus cosine squared theta is equal to 1. And if you plug this in here, not there, if you plug this in here, 2/3 quantity squared, it would all work out to give you what we're going to get here. But that's just not the way my brain was working. So I'm going to hold off on that type of logic and I'm going to work over here. So if the sine of theta is 2/3, then the cosine, because this would be theta, the cosine of theta is going to be the square root of 5 over 3. So now we can calculate this because we know that we're going to do 2 times the sine of theta, and the sine of theta is 2/3, times the cosine of theta, which we now know to be the square root of 5 over 3. And when we multiply all that together, we get 4 root 5 over 9. And so that's that answer. Okay, now we should go on and do the other one that I've hidden here. Let me see if I can find it for you guys. There it is, cosine of 2 theta. And now we have the luxury of trying all of the ones that we have here. But you know what's cool? Let's say we didn't find the cosine of theta. We could just use this one version of cosine 2 theta that only requires us to know the sine. So what we would do in that case is just say, okay, this whole thing is equal to 1 minus 2 times sine squared, and we know that the sine squared theta is going to be 2/3. So I'm rocking a 2/3 here. Don't forget to square it. Then I get 1 minus, let's see, 2 squared is 4, times 2 is 8, 8 over 9, and then therefore we can see that the difference between the two, this would be like a 9 over 9 if you guys are thinking like that, we get 1/9. So the answer to this would be 1/9. Let's try some more. These are kind of fun. So we're going to scroll down here to tangent, and let me see if, well, I think we'll be able to have that with us. So the tangent is going to require that I know the tangent of 2 theta. Well, let's go back and think about what our situation was. Remember, we're in this first quadrant situation. We have 3 being the hypotenuse, 2 being the opposite, and the square root of 5 being the adjacent. And we know that tangent, back in the day when we were dealing with right angle trig, was simply going to be TOA, opposite over adjacent. So we know that the tangent of theta is going to be 2 over the square root of 5. And I know we don't love that because it's not rationalized, but I'm going to rock with that until we're done, and then we'll simplify it if we end up with a radical in the denominator. So we've got 2 times tangent theta, which we know tangent theta to be this. So 2 times 2 over the square root of 5 over 1 minus this thing squared, so we end up with 4 over 5. You get that? 2 times 2, square root of 5, square root of 5 gives me 5. All right, so then we end up with 4 over the square root of 5 over 1 minus that, which is 5 over 5, which is really 5 over 5 minus 4 over 5, which is 1 over 5. You guys with me? And then when I divide by a fraction, I multiply by the reciprocal. This becomes 20 over the square root of 5. Are you guys with me? I hope so. Sometimes I'm running through math and I make mistakes, so you guys will let me know if I did. So 20 over the square root of 5, I'm going to rationalize the denominator by multiplying top and bottom by the square root of 5. When I do that, I get 20 root 5 all over 5, which leads me to the final answer of 4 root 5, because that divides in there. All right, so I'm going to box that so you can keep in mind the flow of the way that was going. And so here we have the cosine of 4 theta. And so the cosine of 4 theta is really just going to treat in the original formula, theta will be 2 theta. Right? So now this will be really helpful if we know the sine of 2 theta and the cosine of 2 theta, which we do. Remember, we got it up here. So we're going to play that role. And I don't care which formula you use. I'm going to, I don't know, for kicks and giggles, let's use this one up here. So I know I'm going to have to do cosine squared 2 theta minus sine squared 2 theta. Does that make sense? Because I'm kind of, yeah. All right, I'm going to believe that you guys are getting me. And so cosine squared 2 theta is going to be 1 over 9 quantity squared. Remember, cosine of 2 theta was 1/9. And then sine squared 2 theta we have over here is the square root of 5 over 3. So I'm going to, or is that what we got? No, we didn't. We got 4 root 5 over 9. My bad. 4 root 5 over 9, and I'm going to square that. And now I'm going to take the difference between the two. So 1 over 81 minus, what would this be? 4 times 4 is 16 times 5 is going to be 80 over 81. And then what do we end up with? We end up with a negative 79. That's not a 9. Try again. A negative 79 over 81. All right, lots of work, but doable. I hope that made sense. Let's go on to another example. So this next example, we're going to be rocking the half angle formulas, and I've taken the liberty of actually moving the little formula chart here so we have it. And so now what we're looking at is the sine of 7 theta. We're going to use a half angle identity. So what this lets us know is that this is like alpha over 2. This angle here is alpha over 2. So what that means is we want to know what alpha is. So if this is half of alpha, then if we double it, we'll get alpha, right? So alpha is equal to double that is going to be 14 pi over 12, which reduces nicely to 7 pi over 6. Pi over 6 we're totally familiar with. That's just a 30-degree angle. Pi over 6 we're all over with two hands. And so because we know that, we will now know so much about this situation. Just for visual reference, pi over 6 is a 30-degree angle in the first quadrant. 7 pi over 6 is a 30-degree angle that is, a 30-degree angle, let's say, in the third quadrant. All right. And so we're thinking third quadrant here as we deal with this. So if I'm finding the sine of that, I'm going to, first of all, recognize that being in the third quadrant means my answer is going to be negative, right? Because the sine is negative in the third quadrant. And the next thing I'm going to do is deal with this 1 minus the cosine of alpha. Alpha is 60 degrees alpha is 30 degrees in the third quadrant where cosine is negative. So I know I'm going to do minus cosine of alpha. That's going to be the square root of 3 over 2. So a negative square root 3 over 2, because that's what the cosine of 30 degrees is, or pi over 6 is. Y'all with me? All right. I hope so. That chart, you got to memorize it. Okay. Over 2. And then, so now this is just an opportunity for us to simplify. So I'm looking at this as 2 over 2. So I've got 2 plus the square root of 3 over 2. That's me joining all of that together. All of that over 2 again, and I'm taking the square root of that. That really is going to be 4, right? So I'm going to have 2 plus the square root of 3 over 4, and I'm taking the square root of that. But when I take the square root of that, this actually becomes 2, and I can just leave my radical at the top. Y'all with me? Y'all with me? And you saw what I did. Lazy math teacher left the negative up. And so all of that's going to be negative. So this is my final answer. My final answer is that, let me write it again, negative the square root of 2 plus the square root of 3, all of that over 2. That is the answer, the exact answer to this situation. Let's try this again with this cosine situation. So cosine, we are given that in this case, the alpha over 2 is equal to 67.5. So the question is, what is alpha? Well, when we double that, what we end up getting is, you guys know, 135 degrees. And so 135 degrees is a pretty good number. We can deal with this because 135 is going to put us in the second quadrant. We know a lot about 135 in terms of it just being a 45-degree angle in the second quadrant. We know in the second quadrant, sine is positive, yet cosine isn't. So keeping all those things in mind will help us. So if we come down here, we don't even need sine, we just need cosine. So the cosine of 67.5 is going to be equal to, we're in the second quadrant where cosine is negative, so I'm going to put a minus sign there. I'm choosing the negative. 1 plus the cosine of alpha. Well, what's the cosine of alpha? What is the cosine of 135 degrees? Cosine of 135 degrees is square root 2 over 2, but negative. And it's negative because we're in the second quadrant. And then I'm going to divide that by 2 and see what I get. So this is, again, a game of simplifying. So let me not forget my negative like last time, 2 over 2. So I'm going to treat this 1 as a 2 over 2. So then I end up with 2 minus the square root of 2 over 2 over 2. Okay. And, just some algebra fun here. And then we're going to recognize that 2 can be lifted up in here in some way, because when you divide by a 2, you're multiplying by 1/2. And when I do that, we end up with, and I'm just going to write the final answer here, the square root of 2 minus the square root of 2 over 2. So when this became a 4, I took the square root of it and it became a 2, and it was no longer underneath the radical. All right, let's box that and say we got that going on. All right, so that's enough for this example. Let's take a look at example 3. looking at example 3, what we're basically going to do is go back to the beginning of the chapter and take a look at an example that they gave us some information about the jets and the angles of these water jets that are creating this beautiful fountain. And what we want is to simplify this ratio of H over D. So since we're going to do that, let's come down here and see if we can figure out what H over D is. H is given as this formula, V squared over 2G times sine squared theta. And that's, let's see, which is V squared over 2G, that's H, got that right? All of that is going to be over D, which is V squared over G times sine of 2 theta. And so we're called to simplify this. And so a couple things can happen. Hopefully you guys can see that the V squareds will kind of cancel out. So would the G's cancel out. And so what I'm left with technically is 1/2 sine squared theta over sine of 2 theta. I'm going to give you a second just to observe that that is true. And so the next thing we need to do is see if we could simplify it even further. So we have some like half angle, we have a double angle formula. Maybe we can do something with that. I'm going to write this down another way. So this is going to become, let me write it like this, sine squared theta over 2, that's that 1/2. And if I'm dividing by sine of 2 theta, then I'm really multiplying by 1 over sine of 2 theta. So technically I can write this as sine of 2 theta like that. Are you guys with me? So that's simplified, but let's see if we can use some of our formulas to simplify even more. So instead of bringing a picture of our formulas, I just brought this down as a thought bubble. The sine of 2 theta is equal to 2 cosine theta sine theta. So I'm going to literally just replace that down here. So I have sine squared theta over 2 cosine theta sine theta times 2, right? Because this 2 was already a part of the formula, right? And then I'm just replacing sine 2 theta with 2 sine cosine, 2 cosine theta sine theta. Y'all know what I'm talking about. You're listening. All right, good. So now we get to have some fun. We get to cancel out some sines here, which is kind of good. So we end up with sine theta over cosine theta, but there's a 4 down here. And you all know that sine theta, cosine theta can be written as tangent. So this ends up being 1/4 tangent theta. That was pretty neat. That was nice having some of those formulas handy so that we could simplify. And I think that's as simple as we can get that. So that's part A. Part B of this problem. So what we're required to do here is really just take this 27 and plug it right into our actually simplified ratio that we have here. So we're talking about the tangent, 1/4 the tangent of 27 degrees, which approximately comes to 13 hundredths around there. That's the ratio that we get. All right, let's take a look at a few more. Okay, so I'm back. I looked at this another time and I thought, okay, I don't know if I want to manipulate this side. I'm not sure. I started thinking about manipulating this side. So you guys know that I really like to use my algebra skills. So I'm going to call sine S. So sine of theta is S, and then C is going to be cosine of theta. So sometimes I'll say I'm S-ing this up. So I'm going to write this cotangent as C over S minus 1. You see how we did that? C over S minus 1 is the numerator, and the denominator is C over S plus 1. I'm going to simplify this by changing the 1's to S's over S's, right? You guys are with me so far. And then so I'm going to get a fraction that's going to look like C minus S over S, right? And C plus S over S. And hopefully you guys can see that this will easily become C minus S over C plus S. With that in mind, I'm going to multiply the numerator and the denominator. You're like, why are you doing this? Let me explain what happened. So in my mind, I was like, I started manipulating the left side, and then it wasn't coming to fruition. I think there is a way, but I just didn't remember it. And so I started fooling with this side, and I was like, oh, this is kind of cool. because when I get c minus s over s and I make it into this thing here, I remembered that cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So how can I get that? By multiplying top and bottom by c plus s, which is just another fancy 1, right? So then I got c squared minus sine squared. So cosine squared minus sine squared is where we are so far, over what happens down here. You remember how you have a perfect square trinomial? So it's going to be c squared plus 2sc plus s squared. Okay, peep this because this is where the fun happens. You guys remember that we've been playing with c squared plus s squared is equal to 1. Wait for it. So this is 1 plus 2sc over c squared minus s squared. And so far you're like, yeah, and however, if you remember that our identity for let me just go back. Let me show you. Our identity for cosine of 2 theta, as we talked about, was cosine squared theta minus sine squared theta. But then our identity for sine of 2 theta is going to be 2 sine cosine. Hold on to those things, right? Let's go back to our problem. So with that awesome breath of fresh air, we can see where we're going. Right now it's starting to look good because cosine squared minus sine squared, or cosine theta squared minus sine squared theta, is indeed that. It is cosine of 2 theta. Let me get back to my black pen. So that is cosine of 2 theta. It's exactly the same thing. So I literally can write that down. Oh, by the way, this is cosine 2 theta. And down in the denominator, we already brought the c squared and the s squared together to get 1. I've got 1 plus 2 cosine, right? So that's 1 plus 2 sine cosine. So this is 2 sine cosine, and that is sine of 2 theta. So that is 1 plus sine of 2 theta. Isn't it beautiful when it all works out? So I hope that wasn't too meandering for you guys and you got where I went with it. First, I just did a little bit of algebra to simplify it, and then that started leading me to the relationships that we started playing with today, the double angle formula and such. And then it led us to here, a true identity. All right. Okay, that's it for us. That's it for this section. I hope that made sense. Please let me know if you have any questions, and I look forward to talking to you all soon. Take care.